Record, yes. Perfect. So all of you can see my screen?
Yes, sir.
Perfect.
Yes.
There's only one rule in the class that till the time you are not clear with any concept, do not let me go ahead. All right. And if you have any kind of doubt, just raise hand. It will show me and we can go on. I'll share the PDF of this class. I'll share the recording of this class. I'll probably post it on YouTube and send the link in the Telegram channel itself. All right. Now we'll start with chapter 1. So if you have studied chapter 1 slightly, so we talk about one thing, which is we talk about reactions, and then we talk about their types. In the types, we have 4 types in general, and then we have 5th type as redox, and then we have sub 2 special types or maybe further types of redox. We have seen corrosion, we have seen acidity, all of that. Here we talk about the combination reaction, we talk about decomposition reaction, we talk about single displacement, and we talk about double displacement, right? And then in all the 4 cases, sorry, in all the 4 cases, you have seen the example also that, okay, give me an example of combination, decomposition, and all of that. And then the more questions which are kind of made on that is they will ask the color of the compound. They'll ask you what is being produced and all of that. So that's factual actually. And we will do that. We'll do all of that what kind of things can happen on all everything. So basically the summary of this chapter is that you have to remember the types: combination, which is also known as synthesis reaction; decomposition, which is also known as analysis reaction; single displacement, which has no fancy name; and double displacement, which is known as metathesis reaction. Then what is redox? We'll talk about what is oxidation, what is reduction. Then we'll talk about where is redox happening when oxidation and reduction both happen. So in most of the cases, we will see that oxidation and reduction, they are happening at the same time, the same reaction. But if I say that, okay, in all the reactions redox happen, no, not necessary. There could be reactions where it's just redox. There could be reaction where it's just oxidation. There could be reactions where it's just reduction, right? Depending on the reaction. So we will see all of that, how it happens. And then we'll talk about okay, what is corrosion, and then we'll say what is acidity and how it is a special case of corrosion. And then we'll also see that what do we mean by this rusting of iron, and how rusting happens, what are the necessity conditions for rusting. There are 2 conditions which should be happening at the same time. One is water and second is oxygen. If you get only water, it won't work. If you get only oxygen, it won't work. So that's the summary of the whole chapter. So today, what we are going to see, we will see nothing of whatever I said. We will talk about that what is a reaction, right? And we'll talk about what are the conditions which must be met for a reaction to happen. So if I talk about chemical reaction, we need to go to class 8th, and we need to talk about a simple thing called physical change versus chemical change. And if you recall, I think most of you must be recalling that what is a physical change and what is a chemical change. We know that in chemical change, a new substance was formed. Whereas in the physical change, no new substance was formed. Correct? And now the question is, sir, how do we figure out that where the new substance was formed and where the new substance was not formed? So very simple method. Suppose this is a process called A to B. And mark my words, I'm not saying it's a chemical reaction. I'm saying it's a process from A to B, right? So just check for the molecular formula of A. Molecular formula of A, and check for the molecular formula of B. If molecular formula of A is equal to molecular formula of B, this is a physical change. It means that no new substance have been produced anyway. But if I say that if molecular formula of A is not equal to molecular formula of B, then we say this is a chemical change. Right? I'm making it slightly mathematical so that you can understand. I'll give an example now. Let's say I'm talking about I have H2O in the liquid state and I gave it some heat and it became H2O in gaseous state. Right? So is it a chemical reaction? No. Because what is the formula here? H2O. What is the formula here? H2O. Is the substance same? Yes. Formula is same. So this is a physical change. If I talk about I have H2O and let's say H2O is in liquid state and I pass some electricity. We all know what will happen. Let's balance it already. This will give you 2H2 in gaseous state plus O2 in gaseous state. Now, if you look at the whole thing, so this is your whole B, this is your whole A. No need to get confused. Sir, you said A and B. Here we have B and C also. Like we are here are two things. I think all of you are pretty smart enough. You can figure it out that, okay, when we talk about B, we talk about the product side kind of, right? When I talk about A, I talk about the reactant side. So here we clearly see that the formulas are not matching. So this is a chemical change. Understand? Are you able to recall class 8 that what was physical change, what was chemical change, right? Now comes the thing that when we talk about a chemical change in simple English words, what do we get? We get word equation. Okay. If I talk about the same chemical change in terms of chemical formula, what do we get? We get skeletal equation. Okay. And if I talk about the chemical change, while we balance everything out, the total number of atoms on the RHS is equal to total number of the LHS. To put it more chemically, I can say that total number of atoms on the reactant side is equal to the total number of products on the total number of atoms on the product side. So we call that, if it's a balanced chemical formula, we call that, okay, this is your balanced chemical reaction or balanced chemical. Let's put it more nicely. This is your balanced chemical equation. Do you understand? There's a physical change, there's a chemical change, right? In chemical change, we can write it in, like, let's say a couple of things. When we write in three forms, we write in just words, we have word equation, we write in just the formula, we have the chemical formula, or skeletal equation. And when we have this properly balanced, we call it the balanced chemical equation. To give you an example, I'll pick this thing only, so it will be easier for you. So I can write that water, when electricity is given, is giving you hydrogen plus oxygen. One way to write this is that when water is electrolyzed, hydrogen and oxygen is produced. Both the two statements can be said, because this is a word equation. This is more appropriate word equation because you are properly making a sentence, right? So this was the first part. If I talk about the second part, I can say that here I won't say H2, 2H2. I'll just simply say that H2, when some electricity is passed, it becomes H2 plus O2. What is this? This is your skeletal equation. And the third part will be when I balance it at 2H2O, when the electricity is passing through it, this becomes 2H2 plus O2. Understand? I'll quite write it. This is your balanced chemical equation. This is your skeletal equation. And this portion is your word equation. Make sense? Maitri, did you get iPad?
Yes, sir.
The iPad Pro.
No.
Okay, the camera is kind of changing continuously.
Huh.
I'm like, Maitri got rich. Any doubts so far? I mean, should not be any doubts.
No.
It's very boring so far, but still just asking for the sake of asking. Sure. The couple of new students you who were kind of on a silent mode, hiding their faces. Uh, any doubt, people, like if you don't feel comfortable in like asking in how to open, that master might find you and kill you. You can use the chat service. You can be anonymous also. You can change your name. Anything is cool. We are very cool people. Any doubt so far? Perfect. Now, I mean, since you people love me and I love you, so I'll just tell you that now what I'm about to teach you is class 12th. And this will come under the topic of chemical kinetics. Right. But we need not to worry about it. And of course, we, so we will study that. But this is about the reaction conditions. Now, what do I mean by that? This is the topic called reaction conditions. Where you will find it, you'll find it in class 12 chemical kinetics. All right, if you wanna go in detail, you know the channel's name, chemistry helpline. Go there, you'll find the notes. So there are neat notes. Just download the chemical kinetics part and go to the end of the chapter. You'll find it. Now, let's understand this one example first. So suppose this is me. This is the master. And let's say this is Garima. The credit goes to her. She took the initiative and everything. And Sunando equally contributed, and we are here. So if the credit has to be given to someone, it was the like the frantic help call from Garima side. Okay, this is too much now. We can't take it anymore. We need some lessons. So let's say this is Garima, and Garima invited her some good friends also, and she did a lot of tarif that okay, this is the very best teacher and all of that. But I could not perform well. I delivered a most boring lecture in chemistry, and now Garima is very embarrassed, and Garima wants to fortify myself. That let's take a patthar and let's open this master's khopadi, and some blood must come out, right? So what is the task? The task is very simple. That master's khopadi should, this is not master's hair, this is master's blood coming from khopdi. Because why? Garima threw a patthar. I'll draw the patthar also. So this is a tiny patthar in tiny Garima's hand. This swing to master's head and blood comes out. Sorry for this violent example, but this is very important to understand uh, the reaction conditions. I hope that you will never be able to forget it. Of course, you're beating master, so how will you be able to forget it? But anyway, very violent kids, I tell you. Now, if master's khopri need to be broken, the first condition is that collision should happen. I mean, suppose Garima sent a patthar with a huge velocity, but master just ducked. Very furtila master, right? No collision happened. So what will happen? Will there be any blood? No. The collision has to happen. Like two molecules or more than two molecules or atoms or anything, whatever you want to say, they have to come in contact. Otherwise, reaction won't happen, right? Second, sufficient energy. Suppose that master is very huge and Garima is very tiny, right? Now, since master is very huge and Garima is very tiny, what can happen that when Garima threw the stone, the velocity was not sufficient. So the patthar came, hit the khopri and fell down. But the velocity was not sufficient. So the head did not get open, right? But what happened that there was some swelling here. This the head has become maybe 1.5x of the original size, but no blood is coming out yet, or no kind of thing, right? The khopri did not open, right? Understand? So there has to be a sufficient energy. There has to be a sufficient threshold of energy. Okay, this much energy must be there while the stone is getting hit. Otherwise, the reaction will not happen. Otherwise, the head will not break. And third, proper orientation. Now, what do I mean? Suppose when Garima threw the stone, it hit me, and it hit me with the required amount of energy. But the problem was that it did not hit my head, it hit my leg. So I might be probably limping for the rest of the week. But was the task achieved that master's khopri should be open? No. We had sufficient energy. The collision also happened, but the orientation was not correct. Instead of head, it hit the leg. So for uh, in order for any chemical reaction to happen, these three conditions are very much required, right? It's called, first is collision, second is sufficient energy, and third is proper orientation, right? Now, let me give you an example of how these things play. You guys are able to see the red color, right? Red color is proper clear to you people. Perfect. Now, suppose I have this reaction that H2 plus O2 gives you 2H2. Let's balance this. 2H2 plus O2 gives you 2H2. Now, if I have to make the molecules, how will it look like? H, 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 O, double bond O, and this is giving you H, O, H, and H, O, H. This is what I've said. 2H2 plus O2 giving you 2H2O. Now, let me rearrange it to make it more visually appealing. Let's say I have H, let's say I have O, and let's say I have H, right? H2, H2, and O2, right? So when we are saying that chemical reaction is taking place, see what happens. Two things happen. First thing is breaking of old bonds. And second thing is formation of new bonds. And how this happens? So basically, this happens in a way that at the time when the old bonds are kind of getting broken, at the same time, new bonds are already forming slowly, slowly. How? Suppose this HH bond is slowly, slowly getting broken, and so is this HH bond, right? In the meanwhile, a new HO bond will be in the formation, and this new HO bond will also be in the formation. I'll do one thing. I'll just change the color so that you will be able to see the bond of formation and bond of which is breaking. So let's talk about first which is breaking. So we say HH is breaking, the HH is breaking, and this OO is breaking. And let's talk about what is being formed. So there will be this ONH which will be formed, this ONH which will be formed, and this ONH which will be formed, and this ONH which will be formed. Right? Now, we started with this thing. We started with this, and we are here. And finally, what we will have? We will have H, O, H, O, H, H. Do you follow? Right? So I'll slightly zoom it out. As you all can see, we started with this thing. Let's say I call it 1. Let's say I call this 2, and let's say I call this 3. So first happened, then second happened, and then third happened, right? So the first thing we call as reactant, right? The second thing we call, third thing we call as product. Do we have a fancy or special name for second thing? Anybody who can answer, who wanna answer? I see a person by the name of Siddhant Sinha. Is the Siddhant Sinha the same Siddhant Sinha who used to sit in the front bench and he used to beat Vihan? Vihan, don't get offended.
No, sir.
Okay, who is this Siddhant Sinha? Can you reveal yourself? I don't see him. But yeah, he is the same Siddhant Sinha. Yes. Hi, Siddhant. Good to see you. What was that charm in Harry Potter for revealing? You guys,
What?
there was a charm in Harry Potter, no, to reveal something. I'm forgetting the charm.
I didn't saw Harry Potter.
Oh my God, you're missing on so much. But good, very good. Go to college, then watch all that stuff. Right now, just focus on the studies for the next 3 years. But anyways, anybody who can tell me what do we call the second thing? Okay, this is a very fancy thing. This is called intermediate complex. All right. So now I'll write it clearly. We started with the reactants. Then we went to intermediate complex. And then we got the products, right? I'll take 2 minutes to talk about this intermediate complex. So you guys know basic English, right? So you guys know the meaning of intermediate and you guys know the meaning of complex, right? Intermediate means somewhere between the reactant and product. The intermediate can, so if you take this thing, right? Is it a product? No. Is it a reactant? No. This thing cannot be determined or cannot be categorized as a product or as a reactant. Clear? And this is highly unstable. Like this thing is highly unstable. This intermediate complex is highly unstable and you can never extract it out that, okay, I have a sample of intermediate complex. No, you can never have that. Either you'll have a reactant or you'll have a product. You will never have intermediate complex. You cannot extract it out, right? And this is a state between reactant and product when the new bonds are not completely formed and the old bonds are not completely broken. It's somewhere the middle stage. All right. Yes, Vihan.
Sir, so the intermediate complex would be when it has achieved the activation or threshold energy,
I'm just coming on
or
that.
is it somewhere in between?
I'm just coming on that only. So if I
Okay,
plot a
sir.
graph, if I plot a graph, uh, let me plot a graph. Yeah. So let's say if I'm plotting a graph on X and Y axis. So let's say this is H2 plus O2 and this is H2O. And this Y axis is called energy and this X axis is called reaction coordinate, which simply means that how far the reaction has gone, right? So, you know, this peak is called intermediate complex. This thing is called product, and this thing is called reactant. Understand? If you cross this thing, if you somehow cross this thing, what do you get? You get product. Just cross this peak, you'll slide down to the product. But if you're not able to cross that thing, you'll slide back to the reactant. And that is why the energy difference is very beautifully called how do I show you that? I can use this. These are quite new things too, so don't judge. All right, do you see the difference? So this difference is called activation energy. And this is defined by a tiny symbol EA, capital E, small a, right? So what is this activation energy? The difference between, I can say that activation energy is the difference between the intermediate complex minus reactant. So if you supply that much of energy to reactants, you get the intermediate complex, and after that you will eventually get the product. Like it's a mathematical equation. You can simply rearrange it and write it as reactant plus EA is equal to intermediate complex. Yes, Chakra.
So can we say that the activation energy is the energy required to break the bond?
Not break the bond. That will be bond dissociation energy.
Okay.
Activation energy
So
is
the
the energy required to achieve the intermediate stage, intermediate complex stage, to be more precise.
so,
We'll
so
talk
the
more about it. We'll talk more about it. Coming on your precise doubt that what is the energy required to break the bond, that's called BDE, bond dissociation energy. And if you keep the pressure constant while you are supplying the energy, so we will use a very fancy word called enthalpy instead of energy. The heat supplied at a constant pressure is called enthalpy. And what is that constant pressure? Standard pressure. All right, standard condition pressure. Any doubt so far? All the students who are present, any doubt so far? Sure. Any person, any doubt, you can come in private, anything. I mean, the whole idea of meeting here is to clear doubts and understand chemistry in a better way. Anybody has any kind of doubt, this is the time, let me know. Jagrat has raised hand again. Yes, Jagrat.
the peak in the intermediate complex. So that energy peak is the energy required to break bonds, or it is something else.
I'll show you. If I have to give this, no, this is the EA. From at the level of reactant till this thing is your EA. Okay. I tried
Yes.
doing it via the fancy tools, but I think that didn't work out. Make sense?
Yes, sir.
All right. So now your task is, I think the most of the previous students who are from Homi Baba, they must have read the NCRT. So you go and read the module which I have shared, the second module. I won't name it because it's getting recorded. Read the second module which I have shared. And those who are not with us, who have not been together, you read the highlighted NCRT first, and if you can make a separate notebook or anything, because we'll be solving more questions also. I'll share this PDF. Write down whatever I have written down in your notebook. We meet next Friday again. We will meet on the same time. We will meet at 9 p.m. sharp. So we will have more time. I have a further engagement.
Sir, Friday or Sunday?
I'm so sorry. Sunday. Sunday. So we meet Sunday 9 p.m. So we will go from 9 to 10. Today we were short of 15-20 minutes because of the first class. So for the old students, the task is read the module. For the new students, the task is read the highlighted NCERT, and the common task for everyone is write down the PDF. I'll share this PDF in the Telegram group. I'll upload the recording in the YouTube. I'll create a YouTube channel and then I'll share it there. Any doubts so far? Sure. Anyone has any suggestion, any feedback, any comment, anything for us?
Sir, you just talked about the bond dissociation energy, right?
Yes.
So, sir, could you just like illustrate it along with the activation energy on the graph?
Bond dissociation energy is, let's say you are taking just an individual, you took individual H2, right? And you are just going to break H2 into H and H. That is your bond dissociation energy. But if you're taking H2 and O2 and you are making H2O, right? That is from the reactant to intermediate complex. That thing will be known as the activation energy.
Sir, but so like that means obviously bond dissociation energy is lesser than the total activation energy.
We cannot make a general statement.
Because sir, I thought there would be some extra energy. So where might that
We
extra energy
cannot
be?
make a general statement. See, in the bond dissociation energy, only one thing is focused. Here, 2-3 things are there. N things could be there, depending on the